Greetings and welcome to another video. In this one we're going to talk about the difference between 2D and 3D programming and how this impacts your engine choice and quite a few other things regarding game creation. So it used to be pretty much the primary way of doing game development was 2D. The hardware and the techniques just simply weren't there for quite a while to do really good 3D gaming. And 2D gaming uses a technology called spriting, or sprites and blitting, where you can look at this image here. You have a sprite or a two-dimensional image, quite often with frames of animation to give the illusion of movement. And then you take these little rectangular areas of video memory and blit them over or copy them over into the video buffer. After you've copied over all the necessary little bits and pieces, you push that particular section of video buffer out to the graphics card, and it gets shown to the user. And you start drawing on the next page. And this technique works really well. They had it refined really good back in the older days of game programming, and it still works fairly well today. Another thing about this technique here of using sprites, as you can see, of course, these are not very square images. You know, it would be very possible for this, at least I'm assuming this is an enemy shot, could be right here, my mouse is pointing, and it shouldn't trigger a collision. But if you did everything in a box area, you can see how the box that this sprite resides in you would be able to fit that image in there. So you can't just simply use the bounding box collision. What you do in sprite-based games is you take, if you have the bounding box of this one colliding with the bounding box of this one, what you do then is you check that overlap area and see, okay, are there any non-transparent pixels? And if there's any non-transparent pixels overlapping each other, hey, we've got a collision, we need to handle this however we're going to handle this for this game. Of course, time marches on, and we have 3D games. This is a 3D game using a flat perspective, but it's still a 3D game. It still has the models, texturing, shaders galore, everything that you would expect in a modern 3D game. And of course, in 3D games, you've got triangles. That's the core technology there. You take a whole bunch of triangles, you slap a material on them, or you slap a texture on them. You use a shader to give it all the glossiness and pretty shininess that you expect. And that's how you compile your image. Collision handling, then, of course, is handled by checking to see whether or not two triangles intersect one another. Usually with some optimizations, perhaps a cylinder collider around this character and a sphere collider around this one, and say, okay, well, if the cylinder and the sphere touch each other, well, then we need to go through the more expensive process of comparing triangles to one another to see if any of the actual triangles touch. Now, how does this impact us for our game engine? Well, knowing what your game engine is good at is important. Also, knowing your target platform. If you're going to be designing games for mobile devices, there's a limit on the number of polygons that you can push out, so it might make more sense to go 2D. So a lot of mobile games, especially the early mobile games, were all 2D. They were all sprite-based. Now, with the processing power on mobile devices getting stronger and stronger and stronger, you're seeing more 3D games on them. It's still not uncommon to see 2D games on those devices, just simply because the processing power is a little bit better for those types of games. Now, so you got to make that decision. Also, your resources. It is easier, although not easy, to make a 2D sprite-based game look good than it is to make a 3D game look good. To do something like this, not only do you have to have someone who understands modeling, you have to have someone who understands animation, someone who understands texturing, someone who understands shaders. It's a lot more labor-intensive. A pixel-based one, all you need is one person who is a good pixel artist, and they can do some amazing stuff. So, like I said, easier, not easy, just easier to do a 2D game. It's far less resource intensive. Now, once you've made that decision, you've got to come upon, what engine do I want to use? If you know you want to do a 2D game, then you might want to stick with the 2D engine. GameMaker, it's got its flaws, but it is an excellent 2D game engine, and so that might be worth looking into. If you're doing a 3D game, however, GameMaker would not be your first choice. Something instead like Unity would be a far better choice for GameMaker than GameMaker for a 3D game. Not to say that you can't do 3D in GameMaker. It's possible. Likewise, it's not to say that you can't do 2D in Unity. There's plenty of projects that prove that quite nicely. You can do 2D in Unity. But Unity is a 3D engine. Everything about Unity is focused on the triangles. Everything. All the built-in collision code, all the built-in shaders, everything is oriented around the idea of you're going to be making a 3D game. And therefore, you kind of got to hit Unity over the head a little bit to get it to play nicely with 2D. So just to show some quick examples here, let's say I've got this material here, this texture. Sorry, this is a texture, not a material yet. And I want to apply this to a shape. All right, fine. We'll go over here and we'll create a cube. Zoom in a little bit over here on the cube. Drop the texture on there, and yay! Well, for the moment, we'll ignore how the cube is all very thoroughly messed up as far as the texturing goes. But we've got the image on there. It works. Yay. If I go look at the game preview and my camera... that's why my cube is off in space someplace. There we go. And I can see my cube. All right. And I'm just going to toss in, because we will need this later. I'm going to toss in a directional light here. Rotate. There we go. All right, so now we can see it a little bit better in the preview, and with the light it gives us a little bit view. Now, this currently is a 3D image. It looks 3D. If we allow this cube to move, just got a quick script here, a very simple script. Pretty much all it does is move according to whatever this speed here is. And if we set it to move, off it goes. Let's pull the camera back here a little bit so we can see it move a little bit less fast. There we go. We're sort of looking at it straight on now. Get my camera over here. And off it goes. And as it moves, we can see the perspective changing in our view. We can see that this is a 3D shape. So this is what Unity is optimized for. All of the collisions and everything is for that. Now, if I wanted to do it to just a flat plane, I can. There's a plane object on here, so I can go to Create Game Object, Other, Plane, and move my plane to 0, 0. Now, the first thing you will notice about this plane, switch to scene view here, is that there's a lot of triangles to this. Now, there's a reason for this. All of these triangles give the plane more detail for shading and lighting work. That's the reason why they've got so many darn triangles for a square. You could do this with 2 triangles, but that won't give you very good shading or lighting. They're assuming you're going to be using this for like billboard textures and things, and so they give it more detail. But I could also slap it on there as well. And yeah, I think I need to change the orientation of the plane here to -90. And let's slow that cube down a little bit. 3. And you can see, it goes off. Okay. Now, it is possible to fairly easily get this to look like a 2D game. Now, how we do that is we fool with the camera. Currently, the projection of the camera, or how it takes that three-dimensional information and squishes it down to a two-dimensional piece of video memory that can be shown on our screen, is currently set to perspective. That means the camera pays attention to depth. It has depth perception. That's what gives us the ability to see that, yes, okay, this cube is sliding along on a floor. Instead, if I change this to orthographic, a couple of things happen. First, you notice that our camera preview here, suddenly things get really, really small. I don't know if you can see it very well on the YouTube video, but you can see the tiny little cube, tiny little cube sailing off into the distance there. What this does is orthographic effectively flattens everything. There is no depth perception anymore. It doesn't matter if I take this cube and pull it further away. Well, actually, first, let's make things larger. So I'm going to grab both my plane and my cube, switch to the scale tool, and scale them up a bit. And you know what? I am going to put in another game tab here, so that way I can see what I'm doing a little bit better. There we go. That makes things nice and visible. Get rid of that tab. There you go. You can see it slowly sliding off. Now notice, unlike the first time, I don't really have any depth perception on this cube here. Actually, let me get my camera and take out that rotation so we're looking at things dead on. It's perfectly flat. It looks like a perfectly flat image, even though we know this is a three-dimensional image. At no point does it ever look like a three-dimensional image. And that has everything to do with the projection. The orthographic projection has no depth to it. If I pull this cube away from this plane, being right in front of the camera's face, you would think, oh, well, the cube should look larger. Nope, same exact size. If I try to move it further away, well, of course, what will happen is it'll just simply disappear behind it. That's sort of expected. But if I move this, let's say, move this down a little bit here. Oh, no, we'll leave it like this. Grab the cube, move it way behind. And again, you would think, okay, well, it's further away, so it should be smaller. Nope. It's just going to come on out. Looks exactly the same as it always has. So that's how you can, at least the first stages of tricking Unity into doing 2D. That's the easy part. The hard part comes in with the collision. Unity has no built-in methods for doing pixel-by-pixel collision detection. So you're on your own for that. And that is also why I highly recommend, if you want to do 2D in Unity, you use one of the Asset Store packages. As you can see, there's a couple, actually more than just a couple, there's quite a few 2D stuff here on the Asset Store. The two main ones I want to point out are the Orthello 2D Framework and the 2D Toolkit. 2D Toolkit's sort of, it's considered the gold standard. It's very popular, it's very mature, it has a lot of options, it's also not free. I'm a cheapskate. I also recognize that a student's discretionable cash is at a premium. And so, or the Orthello 2D Framework, the free version, is an excellent choice to put up against a 2D Toolkit. It's got excellent collision detection for it. And the Pro version has even more options with it. But for the purposes of our class, the Orthello 2D Framework is going to be a very useful download once we get to the visualization, or once we get past the visualization of things. And so that's the primary thing that you face when doing 2D in Unity, is that there is no such thing as pixel-by-pixel collision built in. So you either have to write that yourself or find someone who's already done so. Now, there's quite a bit that I am glossing over here. This is just sort of meant to be sort of an intro to the issue. For the most part, we're going to just sort of be doing the fake 3D. We're not going to be going too deep into the collision detections, because for these courses, we're more focused on the three-dimensional aspects than we are on the 2D. But this should at least be enough to help you understand why we do some of the things we do in the first course. And with that, till the next video.